Now, what's really interesting about this is now that we know that integration just stands for the net area under the curve, if they ask us to integrate something where it creates an area of a figure that we know how to calculate area of. So what do we know how to calculate? Trapezoids, triangles, rectangles, full circles, half circles. There's some things we just know how to do area naturally because we've been doing it since, we were younger. So when they say use the formula for the area of a circle to evaluate this integral from 3 to 6 of the square root of 9 minus x minus 3 squared. Let me remind you of a full circle has a plus or minus there. The positive portion is the upper half of a circle. And if you squared it, you get y squared equals 9 minus x minus 3 squared, or x minus 3 squared plus y squared equals 9. If there's a negative out in front of the square root, that's the bottom half of the circle. If there's a positive and a negative, that's the full circle. You might recall from back in geometry, pre-calc, algebra 2, wherever you did it, that x minus h squared plus y minus k squared equals r squared. That is the formula for a circle. So the first thing we need to do, let's graph the whole circle, and then I'll show you what portion we actually have, okay? So the center of the circle is at 3, 0. Right there. The radius is the square root of 9, or 3. So it's going to go 3 up, 3 down, 3 left, 3 right. And I am going to differentiate by making an upper circle and a lower half. The bottom of the circle is minus the square root of 9 minus x minus 3 squared. So if you ever see the square root of, it would be r squared minus x minus h squared is the kind of general form of a circle that is implicitly solved for y. Okay. But y is always going to be at the 0 mark. Well, whatever. Okay. The area that we are talking about is the upper half only. So we're only talking about that area. And we're only actually more specifically going from 3 to 6. So I guess the formula is only referring to the yellow portion. We are only referring to the area from 3 to 6. Well, that is only a quarter of the circle. So, pi r squared is the formula for the area of a circle. We only need a fourth of it because we only need that portion from 3 to 6. So the exact area, that integral, equals 1/4 pi. Now our radius is 3, so that'd be 3 squared. If you have a pi that pops up in your formula because it was related to a circle, just leave pi in it. Don't write it otherwise. 3 squared is 9. That's 9 pi over 4 square units. I don't know what the units are, but okay. So an integral represents the area under the curve. If there was if there was some negative regions, some regions under the x-axis, you would have to put a negative on those regions. Okay. Now this book focuses on interpreting things as areas a lot. So let's take a look at 2 more that can be interpreted using areas. So let's look at what we know. This is a circle. It's the upper half. The radius is the square root of 1. The center is at 0, 0. So that's what the circle is. We only went from 0 to 1, so it happens to be a quarter of a circle again with radius 1. So this is just 1/4 of pi times 1 squared, which is pi over 4 square units. Now B is kind of interesting because if you draw the line x minus 1 from 0 to 3, let's look what happens. The y-intercept, see right here, y equals x plus b. Your y-intercept is -1, your slope is 1. So you just have to start it at 0 and stop it at 3 because our bounds of integration are 0 to 3. So our lower bound 0, if you plug in 0, you get -1. It has a y-intercept of -1. Then you're going to go up 1 over 1, up 1 over 1. Sorry, I didn't get that part there. Up 1 over 1, up 1 over 1, up 1 over 1. And you're going to get that line. Now, if we think about the area between the line and the x-axis, this first little triangular section here, which they have labeled A2, is a negative area because it's under the x-axis. The A1 region is above the x-axis, so it's positive. So this would be A1 minus A2. We would have to subtract off that area. So if we look at area 1, that bigger triangle that's on top, the base is 2, the height is 2, so it's 1/2 base times height. The triangle created in area 2 goes from 1 to 1. So its base is 1, its height is 1, so that's 1/2 1 times 1. So the area of our upper rectangle, not a rectangle, triangle is 1/2 of 4 or 2. The lower one has a area of 1/2. So 2 is 4/2 minus 1/2. So a net area of 3/2. Yes. Yeah. Okay. So that is one where we're using areas of things we know how to do an area of. We don't have to do. Now, if you did the long formula for these, you would get those areas, but it would not be a fun process.